My name is Steve Spatz, and this is a recording of the training on the Vermont 2020 RBES as a training platform and opportunity for joining the Efficiency Vermont Residential Construction Professionals EEN Trade Ally Group. So this will be a broad overview of information on how the Vermont RBES Code works, and will give you enough content to be able to hopefully pass the proficiency quiz for joining our EEN trade group. The content included in this training is copyrighted by the International Code Council. So a lot of the content that you will see is directly attributed to the ICC. All rights are reserved. So the Vermont Residential Building Energy Standards is a law that's been in place since 1997, enacted by the legislature via Act 20. It is a code based on the International Energy Conservation Code published by the ICC, and it is updated on a typically 3-year cycle with revisions that align with the IECC and then what is required by the state of Vermont's policies for our climate goals. The current code was put into effect as of September 1st, 2020. So any new buildings or additions, alterations built or enacted after September 1st, 2020 need to meet the requirements of the 2020 code. There are 2 reference documents in regard to the RBES. There is the full language of the ICC published code, which can be found on the ICC website and through links on the Department of Public Service websites to get you there as well. And then Efficiency Vermont also publishes in partnership with the Department of Public Service as the Energy Code Assistance Center, a handbook, which is a guide to interpretations of the code and how to apply the code for builders. So an important distinction to understand. The full code document from the ICC is what should be referenced to ensure that a building is being built compliant specifically to what the law requires. So the handbook is an excellent guide to move you along that path, but the ICC document should be what is referenced for the law. Accessing this content, you can find this both through Efficiency Vermont's Trade Partners site, as well as through the ICC site directly as well, and the Vermont Department of Public Service website. So Efficiency Vermont's role is we are not the code police. We are here to support the understanding and application of code in Vermont. We support and run the Energy Code Assistance Center. So you can call this toll-free number to reach one of our customer support representatives who can help answer questions in regard to the code and or connect you with an energy consultant such as myself or someone else within Efficiency Vermont who can get into more detail with you in regard to code questions. The Vermont Department of Public Service is the regulatory entity that basically owns the code here in Vermont. So any questions about the actual application of the code and implementation of the code would be directed to the Vermont Department of Public Service. So 2020 Vermont RBES. So buildings that must comply are any new construction, low-rise residential buildings. So 1 and 2 family dwellings, any multifamily housing that's 3 stories or less. RBES does not cover commercial buildings. They are covered by the Commercial Building Energy Standard, which is revised on the same schedule as the RBES. If you have a mixed-use building with commercial application on the lower street level and then residential units above, both codes come into play in that circumstance. Additions are treated as new construction buildings, so the addition needs to conform to the requirements of the 2020 RBES as if it were a new home. Does not mean that the rest of the building needs to be brought up to meet the requirements of the current code. Only the addition needs to conform. Renovations and alterations have their own requirements that are defined in Chapter 5 of the code under existing homes, as are repairs as well too. If the project falls under the jurisdiction of Act 250, whether it's a development or if it is a specific circumstance where there's an Act 250 umbrella over the project, stretch code needs to be met, which is a higher level of performance than base code is requiring. And also the city of South Burlington has adopted the stretch code as their local requirement, more stringent than what the base code requires. There are some exemptions in the code. Any unconditioned building, outbuildings, sheds, unheated garages, etc. Those are considered unconditioned buildings. Mobile homes have their own federal requirements. Seasonally heated or conditioned buildings, so that are not meant to be lived in year-round, and owner-built homes. Owner-built homes have their own distinct call-out in the code that is very specific. So if you are planning to build your own home, general contract it yourself, and live in the home upon completion, you're allowed exemptions from meeting the full compliance with the RBES code. You still need to complete a code certificate that details what was installed in the building, but there is an allowance there for alterations away from the strict requirements of RBES. Liability is where the teeth of the code comes into play. There are no code officials in the state of Vermont. Efficiency Vermont is not a code enforcement entity. There is not that mechanism set up or regulation set up that way in the state. So unless there is a local code official who is overseeing construction in their jurisdiction, it is entirely up to the builder to verify and show compliance that the building has met the requirements of RBES in full. A homeowner may take civil action against the builder or the person certifying the building as compliant with the code or lack thereof if they've never have completed the code certificate nor built the building to meet the standard. So these claims can be filed within a period of 6 years. It doesn't mean that after that 6-year period, a builder may not be liable for faults that were identified in the building that can be linked back to non-code compliance, but it would not fall under the direct jurisdiction of an RBES filing at that point. There's two main components to the code. There's the performance requirements, which we'll cover in detail as far as the actual specifications for how the building is put together. And then there is a reporting compliance requirement, which is actually completing a certificate that details the components of the building and verifies that the building has met in full the requirements of the RBES. That document is required to be completed in full by the builder or engineer or whatever entity it is that is basically in control of the outcomes of the project. This document needs to be completed in full, signed, and then a copy of it filed with the town that the home was built in, or the retrofit, or whatever applicable project type was done in. Needs to be reported in the town records, and then a copy of the code certificate also submitted to the Vermont Department of Public Service for public record. And then a copy of this certificate will be posted within the home, somewhere in a conspicuous area, typically in the utility room, that will stay with the home. So general requirements structure for how the code is put together. So the Vermont RBES is laid out in the manner that typically all codes are that are written, model codes that are written by the ICC. It's written as a design document. So the way it is laid out, the chapters kind of go basically from design and specification through to project completion. So if you can look at the code that way, you can and reference the code that way at design stage, rather than trying to figure out how the building met the code upon completion, you'll have more success in actually meeting the full requirements of the code. So there are 5 chapters of content, and then the 6th chapter has reference standards that are used within the document. So chapter 1 is scope and administration, basically covers the administrative side of the code. Chapter 2 is essentially a glossary of terms and materials and conditions. So basically anything that would be referenced in the code is defined in chapter 2. Chapter 3 covers details for design conditions and mechanical and material systems to be used in the building, design criteria for whole house ventilation systems, and details around combustion safety. The bulk of the performance requirements in the code are contained in chapter 4. So this is where most of the actual specification and installation requirements are detailed in the code. Chapter 5 is specific to existing homes and basically references back to content that is in chapters 3 and 4 and how they apply to an existing building project, whether that's an addition, alteration, repair, or change of occupancy. Then finally, chapter 6, again, is just a index of industries standards that are referenced in association with the requirements of the Vermont RBES. So getting into the details of the actual specification and compliance requirements for new construction and additions. The sections that are referenced here, the reference section numbers come directly from the ICC code document. So if you look into the ICC website and look for these section areas, you'll be able to reference the full content from the code. So there are 3 options to comply with the code. You have a package plus points or prescriptive compliance method that is allowed. That's detailed in sections R402 through R404. Alternatively, a builder can choose to use REScheck software, which is an online web-based energy modeling tool that you input your building component specifications to, and it will give you a numerical index as to whether or not what you're planning to build and those specifications will meet the intent of the code or not. And finally, the third option to show compliance would be to work with a third party by hiring a home energy rater or HRVE rater who will do building energy modeling and verification of measures installed on behalf of the builder, and essentially provide the builder then with documentation upon project completion that will be used to show RBES compliance. So package plus points for code, basically this is the most commonly referenced way of defining the code requirements for performance, because it goes into detail about what specific R values are required for different components of the building. But the way this essentially works is a builder will choose a package of component performance within a table, and then based on the size of the building, the square footage of the home, points will need to be attained to enhance the performance of the building from what the packages specify. So we'll cover those now in more detail. So here's the reference table from the code book. So there are 5 packages here that a builder can choose from. Package 5 is specific to log homes, which has its own ICC standard. So out of the remaining 4 packages, packages 1, 3, and 4 are stick-built assemblies. Package 2 is specific to SIPS panel construction. So the intent of how this works is a builder would choose one of these packages and meet all of the specifications outlined in that column relating to that package, and that'll meet your base requirements for performance of the building envelope, essentially. So you cannot pick and choose from one package to another here. You have to pick a package and then meet the specifics underneath that package in full. So that is the base kind of like ground level of what is required for code compliance using the prescriptive method. From here, you need to earn points that improve the outcomes of the building beyond what's called for in those prescriptive packages. And those points are based on the square footage of the home. So this table R402.1.2.2 in the ICC code, gives you the parameters of points needed based on size of the home. So the bigger the house or the addition, the more points are needed. That's followed by another table in the code, which gives you your options for obtaining points. So you can improve aspects of the building envelope to obtain points. You can improve the air leakage rate of the building envelope by making the building tighter and putting in balanced ventilation systems to gain points. You can put in efficient heating and cooling equipment to gain points. You can install low flow fixtures within the home as a way of gaining points, options with renewable energy and other forward-thinking measures that can obtain you points as well too. So that is the requirement. You need to pick a package, meet the full specifications outlined in that package, determine how many finished square feet the building is, and figure out how many points you need to obtain, reference this table to obtain those points, and then follow the installation mandatory requirements, which we'll cover here momentarily. Alternatively to that prescriptive package approach, as I mentioned, a builder can choose to use REScheck software. This is detailed in section 405 of the code. So this is in place of following the specifications in one of those packages. The builder can go to the site that hosts the REScheck software, which can be found at this link directly, or you can go to the Vermont Department of Public Service website and be linked to that REScheck software from there. And then this gives you the option of inputting performance criteria into the software and kind of trading options to show whether or not your building meets the standard based, again, on a numerical comparison of what a base compliant code would require versus what your specifications are you're inputting into the software. Finally, as an alternative to that, again, is to work with a third-party HRV rater, which would mean hiring a ResNet certified rater who will take your plans and specifications, again, ideally at design stage, to review. They will be able to do a preliminary rating for you at that point, which will show where your building plans and specification land in reference to code compliance and whether or not what you have designed will meet, in fact, the code if it's built. At that point, you can make any adjustments or changes to the building specifications to make sure that it complies with code. And at that point, you can move forward confidently with construction, knowing that what you're building will comply with the code upon completion. This method requires that HRV rater come in and do a mid-construction inspection after insulation measures have been installed, and then come out and do final performance testing on the building and documentation in order to provide the final documentation to show code compliance. Stretch code, again, comes into play if you have a building that is being built that lands within the jurisdiction of an Act 250 permit, or if you're building within the town of South Burlington, as South Burlington has adopted stretch code as their local requirement. So stretch code essentially is upping the ante on what the base code requires. So you can meet stretch code prescriptively by using the package plus points approach, though you're limited to 3 packages instead of 5 with stretch code. And you can see here in stretch code that you have to do continuous insulation on above grade walls, whereas the base code in package 4 allows you to just still do cavity only insulation. It requires you to have a little bit better foundation wall insulation, depending on the package, a little bit better windows, and more importantly here is you're required to put in balanced heat recovery ventilation, whereas base code you're still allowed to use exhaust only if you so choose. So same approach here, you pick one of the 3 packages, meet the full criteria of that package as your base requirement. Then depending on the square footage of the home, you need to obtain points again from a separate table based on the square footage. I don't have that other table shown here, but there is a specific table in the code for stretch code that looks the same as the base code points table, but is specific to stretch. One difference with stretch code compliance is that you cannot use REScheck software to show compliance for code. You have to either use the package plus points approach or hire and work with a HRV rater to show compliance. So you're restricted to those 2 compliance options when needing to comply with stretch code. So package plus points approach, again, same as base code. Pick one of the 3 packages, determine the number of points, and then incorporate a sufficient number of those points into the building specification from the specific stretch code table to show compliance. The difference in the HRS score requirement for stretch code is that base code, you need to have a maximum HRS rating of 61, whereas for stretch code, that maximum HRS rating is 54. So that details the specific component requirements for meeting the code, as in R values and U values and air leakage rates, et cetera, for the building envelope. But then there are also mandatory performance requirements that are called out within the code. So this essentially means how materials and systems and equipment is installed in the building so that it actually performs in a way that's designed to work. So this section covers some of the more distinct or prominent mandatory details and installation requirements called out in code, but it's not a fully inclusive list. So the full list of mandatory requirements can be found in this section R402.1.2.2. So we'll start with an exemption. So where the code requires in the prescriptive tables that a minimum R value for an open attic space of R49, R38 is permissible if that R38 insulation carries fully over at full height, uncompressed over the top plates of the exterior walls. So that's an allowable exemption to R49, is to have a uniform thickness of R38 throughout the whole attic space. The same exemption exists for R60, where R49 can be allowed, again, if it's a full uncompressed height over the top plates of the exterior walls. Section R402.2.1 covers in detail unvented roof assemblies. So again, R49 is the minimum R value for any roof assembly, attic assembly, whether it's an open attic or if it is an enclosed rafter assembly. So there are 3 options for doing unvented enclosed roof assemblies. One option is air impermeable insulation. So essentially closed cell foam to fill the cavity to an equivalent R value of R49, whereas that insulation needs to be in direct contact with the underside of the roof deck. An alternative to that is to do cavity fill insulation within the rafter cavity of any insulation type, and then add what is equivalent to half of the R value of what's in that cavity in rigid insulation board above the roof deck to prevent the roof deck from becoming a condensation point within the overall assembly. So that's another alternative for unvented roof assembly. And then finally, a mix of air impermeable and air permeable insulation, more commonly known as a flash and bat or flash and fill insulation, where you're getting half of the overall R49 R value in a closed cell foam insulation that is in direct contact with the roof deck. And then the balance of the R value is made up with another insulation type of fiberglass, cellulose, rock wool, open cell foam to get to your R49 minimum. Eave baffles are required in any attic or roof assembly type to prevent wind washing from the soffits and the eaves. So this is a mandatory requirement for any attic or roof assembly. Access hatches or doors need to be treated as exterior entry points to unconditioned space. So they need to be treated in a manner of equivalent R value to the assemblies that they're being installed in. So an equivalent R value or close to it of what the R value requirement is for the knee wall or attic space that the access hatch is located in. The access hatch needs to be installed against a compressive weather stripping to prevent air leakage through the panel and getting around that to the outside. Any exposed floors that are over truly unconditioned space or cantilevered floors require that the insulation in those cavities be in direct contact with the conditioned side of the assembly. So the warm side of the assembly, there cannot be an air gap between the insulation and the finished floor above. Foundation wall insulation needs to be at a minimum of 10 feet, basically the full wall height to 10 feet. So if you somehow have a foundation wall that is greater than 10 feet, the insulation needs to at least come down to 10 feet below grade or to full wall height if it's less than that. There are no requirements as to where and what side of the foundation wall foundation insulation is applied. It can be installed on the inside, it can be installed on the outside, it can be installed in between. It can be a framed wall with cavity fill insulation. So there are many options for insulating foundation walls. Any exposed foams that are within a space that is accessible to the occupants or for service needs to have an ignition barrier facing on the foam or something else covering it to prevent ignition of the material. So this goes for open attic spaces where exposed foams would be in place, knee wall access points, basements, crawl spaces, etc. So the ignition barrier needs to be in place over the exposed foams. Slab on grade floors. So a slab on grade is considered any floor surface that's less than 12 inches below grade. Needs to be insulated with the requirements called out for in the prescriptive tables of R15 down to a minimum of 4 feet. And that 4 feet can be either vertical or it can be a combination of vertical and underneath the slab. So you basically need to insulate at least 3.5 to 4 feet below the slab at the perimeter of any exposed foundation or slab, I mean. So this applies for a slab on grade home or a walkout section of a basement in a full basement type setting. There is an exemption in the table R402.1.2 for R10 as the vertical slab edge insulation, and then R7.5 underneath the entire slab as an alternative to doing R15 at the slab edge only. Condensation and moisture mitigation in wall assemblies is a bigger part of the picture of the building science side of the code, and there are specific requirements called out in the code in regard to vapor retarders. So different classes of vapor retarder types, class 1s, 2, or 3, depending on the wall assembly over which that vapor retarder will be installed. But measures need to be put into place to prevent the bulk loading of interior moisture vapor into building assemblies to prevent the concern of condensation from occurring within these building assemblies. There's a lot of good content in the code handbook that I mentioned that goes into detail about moisture safe building assemblies. So there are these construction details which are illustrated in the handbook, are different ways to approaching continuous wall insulation assemblies that are considered moisture safe, condensation safe. So a great reference to have and to look at in interpretation of the code. And then there are also some examples of what not to do when doing continuous insulation as well. Section R402.4 details the specifics of the air leakage requirements for the building envelope. So this covers the primary and mandatory air leakage pathways that need to be addressed in the building envelope to meet the 3 ACH or 2 ACH criteria that are called out in base code and stretch. So this section covers in detail the different material types that can be used or should be used as air barrier material and the ways of combining those materials together to create a uniform, unbroken barrier around the full perimeter of the building envelope. The 2020 RBES does require that the air leakage of the building envelope is tested and verified upon project completion by a third party to verify that the building does in fact meet the 3 ACH or 2 ACH maximum air leakage rate. So this is no longer just a builder verified component of the code. It is actually something that needs to be done by a third party blower door test to verify and document that the building did in fact meet those maximum air leakage rate requirements. So these are just some details to be aware of within the building that are specifically called out. So any shower or tub assembly that's adjacent to an exterior wall needs to have a rigid air barrier separating from the bathroom space to the cavity insulation behind it. Otherwise, that wall is guaranteed to have moisture and mold and potential structural failure at some point in its future. This is another image pulled from the RBES Handbook. So these are two illustrations of section details that show specific details in place of how to do an exterior defined air barrier versus an interior defined air barrier. Again, it's an assembly of parts, so it's important to understand where the different details come into play to make it uniform. As well, in the handbook, there is a checklist that goes into specific detail about all of these transition areas and changes in the building envelope that need to be addressed to meet the full criteria of the air leakage requirements, and to ensure that when that testing is done upon project completion, that you will not exceed the 3 ACH or 2 ACH maximums. And to just reiterate that, this is the language from the code that details that testing requirement as required by law here now moving forward for any new construction. Any wood burning fireplaces or wood stoves need to have tight fitting doors to seal off the firebox from indoor air, and also have outdoor combustion air piped directly to the firebox. So we cannot rely on combustion air coming from within the building for the combustion of the wood in the firebox and for the exhausting of those smoke and byproducts up the chimney. Outdoor air is required, and a sealed gasketed enclosure is required. And another note from section R305 is that any new construction built to meet the full requirements of the Vermont 2020 RBES shall be considered of unusually tight construction by the fuel regulations for combustion safety and combustion requirements for closed combustion systems. So basically any equipment going into a building meeting the requirements of the 2020 RBES needs to be closed combustion, not open combustion. Finally, in Chapter 4, Section R403 details the system requirements for mechanicals in the building. So this covers the sizing requirements for both design load and system sizing, equipment sizing, as well as duct design, insulation, and installation, domestic hot water piping, mechanical ventilation, snow melt systems, controls, thermostats, etc. So it's essentially the mechanical system requirements of the code. In Chapter 3 as well, Section R304, this covers the design criteria for residential ventilation systems. So whole house ventilation is mandatory in RBES, both for base code and for stretch code. So every home needs to have a whole house ventilation system, and that can be either exhaust only or balanced for base code, whereas stretch code you're required to use a balanced system. So in base code, you can show compliance either prescriptively in reference to a table I'll show you next, or you can actually do a calculation design for the specific needs of the building based on the square footage, number of occupants, exposure of the building, building envelope, air leakage, etc. And the three methodologies that can be used to define that ventilation rate for the specific building is the ASHRAE 62.2, the Building Science Core Standard 01/2015, or the Passive House Ventilation Standard. But that being said, there is a table in the code, R304.6, that allows you to comply with the mechanical ventilation whole house requirements prescriptively, meaning that you can put in a single bath fan rated at 100 CFM in a 3-bedroom house, no matter how big the house is of square footage, no matter how many occupants, and you can be compliant with the requirements for whole house ventilation, so long as that exhaust only system has controls that allows that fan to come on automatically throughout the day to provide at least exhaust side ventilation of the building. So an exhaust only system is literally just sucking air out of the building, and you're relying on leaks that exist in the building envelope to bring in your outdoor air, fresh air exchange into the building. In a home built to meet the 2020 RBES, you will end up depressurizing the building more than likely if you're relying on an exhaust only system. So you're going to create negative pressure in the building when the bath fan is running. That can be a problem when you're trying to use a wood stove or a fireplace or potentially backdrafting other equipment in the building. So it's allowable by code, but it is by no means ideal for where we're at with building envelope performance. Alternatively, you can use a balanced ventilation system where you're extracting air from bathrooms, kitchen, mudroom, point source areas where you're going to have bulk moisture building up in the building. And at the same time, you're exhausting that CFM of air to the outside to remove that moisture and other pollutants from the home. You're bringing in an equivalent amount of that fresh air from the outside that is being ducted and piped into bedrooms and living spaces. And those two air streams cross paths in a heat exchanger box where the outgoing airstream exchanges its heat with the incoming airstream and conditions that fresh air to be ducted throughout the whole building. No matter which whole house ventilation system type you choose to go with, whether exhaust only or balanced, you are required to meet a minimum CFM in bathrooms that contain a shower, tub, spa, anything that generates bulk moisture. That minimum ventilation requirement is 50 CFM if it's going to be a standalone exhaust fan in the bathroom that's operated on a switch, known as intermittent, or if you're using a whole house balanced system, that system needs to move a minimum of 20 CFM if it's going to be running continuously to provide the local ventilation exhaust requirement. So in summary, to meet the base code, an HRV or balanced ventilation system is not required if you're using the packages plus points approach. If you're going to use REScheck, you are required to use balanced ventilation. You cannot do exhaust only. If you need to meet stretch code, then an HRV balanced ventilation system is required. That being said as well, in the code, if an HRV or ERV balanced ventilation system is required, it must have an ECM fan, ECM motor fan, and it must meet a minimum performance requirement of 70% heat recovery if it's an HRV, or 65% heat recovery if it's an ERV. And you'll find that information at the Home Ventilation Institute listed flow rate that can be found online at hvi.org. So in summary, whole house ventilation system means an automatically operated ventilation system required for any building, cannot just be an on-off switch in the bathroom for use by the occupant at their leisure. It needs to be something that runs automatically throughout the day to provide air exchange. The consequence for not having these systems installed is inevitably a high relative humidity within the building that can lead to, if not significant issues with condensation within wall assemblies, but more often than not, condensation on windows, which can be hard to manage with any other way than by having a good ventilation system installed in the building. So Efficiency Vermont, what we're here for, who's got your back? That's us. We, again, have the support of the Energy Code Assistance Center. So if you have questions on code, whether your building needs to comply, how to comply, questions on interpreting the code, you can always reach us at the toll-free number here. If you have questions about the administration and application of the code, you can reach the Vermont Department of Public Service with those questions. So again, this content has been partial, if not full, pulled and referenced from copyrighted material from the International Code Council, all rights reserved. So thank you for your time. Feel free to reach out to me as well directly if you have questions in regard to code, and we'll take it from there. Thank you very much.